Thermochemistry Extra Practice Example number 3. I highly recommend in all of these examples that you take good notes, follow through, understand the pieces that I'm going through in the video, and then attempt some on your own. Just copying down the work without understanding where the pieces come will not create success for you on an assessment. In this problem here, we know that we're solving for heat. We have several different formulas on our formula card that we can use to solve for heat. However, if it says heat capacity, like it says right here, or bomb calorimeter, we know we need to use this formula. So again, we use this formula. Notice this formula does not have mass. Okay, it doesn't have mass. And how do we know to use this one? Because I read the word heat capacity in my problem, or I would have read the word bomb calorimeter. So negative heat capacity, this is a capital C versus the other formula we used in example 1, that is a lowercase c, and that is specific heat. Heat capacity and specific heat are not the same thing. Similar, but not the same thing. So we have Q equals negative heat capacity times change in temperature. So we will begin this problem by plugging in the pieces that we have in this problem that corresponds to heat capacity and change in temperature. So here's the heat capacity. It's right here in our word problem. Okay, the negative becomes from this, and then we're going to take your final temperature minus your initial temperature, end minus beginning. When we do all this math and crank it out, we get this value as a positive value. Now, this problem asks us to calculate Q, but for what? Well, it asks us to calculate Q for 1 mole of manganese borate when it dissolves. We have calculated a Q in our calorimeter, in our bomb calorimeter. We calculated Q, and we got this much Q. Now, where did this come from? Well, remember that this is based on putting this amount in and getting a temperature change, and then we got this much Q. So this is where we have to evaluate in versus out. All Q's are really in versus out. So let's look at here and see that our in is here. We put this much in, 6790 grams, and we got this much out. So if I change the 6790 to a different number, that's going to change this. So my in versus out would change. I want to know in this problem, or we want to know in this problem, how much there is in 1 mole. We know how much heat there is if there's 6790 grams. This is our in versus out. It's a new relationship that we can use in converting. So we need to solve this for 1 mole of magnesium borate. So in versus out, we're going to start by looking at 1 mole. So we're going to start with 1 mole of magnesium borate. That's what we want to know. We know that we can use the periodic table number because remember, our in versus out is grams versus joules. So that's my relationship here. If I put this much in, I get this much out. The units are grams per joules. So I got to get moles into grams to be able to relate grams to joules. So I'm going to take the periodic table number to get to grams, because anytime I have moles and I have a chemical, I can get to grams and vice versa. We know that 1 mole of magnesium borate equals this periodic table number of 113.75 grams of magnesium borate. So now moles of, I think I've said magnesium, apologize, that's manganese. Sorry, it's late in the evening. This whole time I think I've said magnesium, it's manganese. Manganese borate, those cancel, and I have grams here. So now I can put my in versus my out. So I'm going to take and I'm going to do 6790 grams in of manganese borate, and I get out this much heat. And then I calculate the value, and this is my final answer. And that unit is wrong. I apologize. Let me fix that. I copied and pasted it from the other page. It should have been joules, not liters. All right. So again, the biggest hang up on this one is in versus out, right? This is the relationship. 6790 to this. A lot of folks want to start with the 6790. That would not be correct, because then you'd be putting a relationship that doesn't exist down here. This is true. We know this relationship exists from the periodic table, and we know this relationship exists from the in versus out. Again, apologize. I think I called this magnesium, and it is manganese borate.